Hiya Seven, today we're going to move on to solving equations, and that is to do with algebra. So what I'd like to do first of all is a blank page retrieval on algebra. So that means make a brainstorm on your books, maybe leave like half a page or 3/4 of a page to do it. Just write down everything you possibly know about algebra. So go for that now, pause the video, give yourself about 3 or 4 minutes to do that. Or just until you've run out of ideas, and then I'll just say some of the things that you could have maybe come up with. So go for that now, and then I'll go through mine. So some of the things you could have come up with are what algebra is about, using letters to represent numbers usually. One thing I will say about when we do letters, remember we do our algebra X, we're not going to do our X's like that because they look like multiplication signs, so do an algebra X from now on all the time. So Y is an example, X is an example, Y is an example, sometimes use A, sometimes use N, and so on and so on and so on. Something else that you've learnt about before is substitution. That's where, say if you had N plus 2 and you said N is equal to 3, then we would sub that in and get 5. So let's say something equals N plus T, then if we subbed in, so substitution, if we subbed in 3, then we get out what our output is. Something else you could have had is like terms. So remember, that's where they have the same letter and the same power. So I'll just write down some like terms here. So 2a and 5a, 6a, and so on and so on and so on, minus 3a. 4b squared, b squared, 5b squared, and so on and so on. So anything with same letter or same letter, same power. So numbers are all like terms because they've got no letters or no powers after them. So 3, 5, 8. I'll just show some non-examples as well. So these are non-examples. We might have 2a and 2a squared are not like terms because look, they've got a different power. 3b and 3c are not like terms because they've got different letters. Something else you could have had is collecting like terms, so let's sort of draw an arrow from that. And that's also sometimes known as simplifying. So that's where, say we had 3a plus 4a, we could simplify that to 7a, because there's 7 lots of a. Or if we had 3a times 4a, then remember we times the big numbers together and we times the letters together, so that would be 12a squared. But this was something I think we'd sort of struggled with a bit, but the first bit, this bit here, was something we were a bit more familiar with. I'll just do one more example. 2a plus 3b plus 4a plus 5b. Well, we would remember when we did squares around our like term and the sign in front of it, so that would be 6a. Then there's a positive 3b plus 5b, so that would be 8b. So that's how we would simplify that. So that's another thing you could have, collecting like terms. And yeah, that's. Oh, there's one more thing I wanted to mention. So if you didn't get any of this down, then get it down as well. Just add it to your blank page retrieval with it in a different colour. But if you've already started in the same colour, just carry on. Remember, when we've got, say, 1x, I'll do it in red again, so it's a non-example. We wouldn't write 1x, but what would we write? We would just write x, because that shows we've got one lot of x. We don't need that 1 there. So yeah, that was the last thing I wanted to mention, really. So on to solving equations, and the aim of solving equations is to say what your letter is equal to. So what I'm gonna start with what a letter is equal to first. So I'm gonna say that x is equal to 10. Now normally that would be our end goal. We would finish our question, we go, there we go, we've found what x is, it equals to 10. But I'm just gonna start with x equals 10 in this case. And then I'm gonna build up, so build backwards up to an equation that you might be able to solve by the end of this sort of unit. So I can say that x equals 10. Well, something else I could say then is that, oh yeah, there's something else I wanted to add up here as well, is that, and it's sort of building on this a bit, is if you've got a letter next to a number, then that's the same as saying 3 times a. So remember, we don't put that times sign in there just to sort of make our lives a bit easier, and so we don't have many x's in there. But remember, letter next to number means you're multiplying them together. And also, if you had a letter over a number, then that means divided by 3. But we'd normally write it sort of like a fraction like that. So let's say I start with x equals 10. Then I'm going to build up to an equation. Well, if I times this side by 2, then I've got 2x, because I'm timesing by 2, but I can't say that 2x equals 10 because I know x equals 10. So what I have to do is times both sides by 2. And then I can test, is that still right? So if I subbed x equals 10 into there, would this equation make sense? Well, what this is telling me to do is do 2 times 10 equals 20. Well, 20 does equal 20, so yes, right. So if I do the same thing to both sides, then my equation is still true. So let's just do something else to the equation. If I add 15 to this side, then I've got 2x add 15. Remember, I can't simplify that any further because they're not like terms, so I can't add them together. But I'd also have to add 15 to this side as well, because I need to do the same to both sides to keep it balanced. So this would be 35. Now I can sub, so I can sub x equals 10 back into here, and that would be 2 times 10 plus 15, and what we should find is it equals 35. Well, let's test that. 2 times 10 is 20, add 15 is 35, so yeah, that's still an equation that makes sense on the basis that x equals 10. So the main thing I want you to pick out here is that I'm doing the same thing to both sides to keep the equation like accurate and true, to keep it as the same, saying the same thing, or keep the letter the same value. I have to do the same thing to both sides to keep it in balance. So one big thing to remember with solving equations, same thing to both sides. Let's write that down as like a keynote. So get this down in your book. And by both sides, I mean both sides of the equal sign. So I'd normally call this the left-hand side and this the right-hand side. And notice that I'm doing the same thing, timesing by 2. Then I'm adding 15. Another thing that comes out from this, and what you'd normally do is, we'd normally get a question like this and work back the other way. But I would be working down the page. We work down the page, just like when we did bid mass. When we do our working, we're gonna follow it down the page rather than across. We're not gonna do that. And then finally, we always, and this is where I'm gonna get some questions for you in a second, we always do the inverse. What do I mean by inverse? I mean opposite. So if something is saying times by 2, to undo that, we do the inverse, we divide by 2. So I'll show you what I mean by that. I'm going to do a worked example here. I'll do it in silence first of all, then I'll talk through it. And then I'll give you a your turn one, so you can see if you can do it. So I'll just find questions quickly. Right, first question. So I've done What I'm doing here is doing the inverse and doing the same thing to both sides. What do I mean by doing the inverse? Well, this means that I'm doing 4 times by x. So to undo that, I need to divide both sides by 4, because the reason behind that is because if I do 4, if I do 4 times x divided by 4, well, what's 4 divided by 4? That's 1, so I'm left with one lot of x, which is what I've got here. It's what I'm aiming for. So that's like the extra annotation. You don't necessarily need to get that down. The main thing to notice is, well, what is happening to x at the moment, and how do I undo that? So at the moment we're multiplying by 4. I do the inverse of that by dividing by 4. So I notice that left me with one lot of x, because 4 divided by 4 is 1. 8 divided by 4, well, that's 2. Right, I'm going to give you one to have a go at now. So pause the video, have a go at it, and then I'll go through it. So hopefully you've had a go at it now. What we're doing is we've got 4 times by x again. So we're going to do exactly the same thing as before and divide by 4, because we're doing the inverse of multiplying by 4. Inverse of multiplying is dividing. So then I'm left with x equals, well, what's 20 divided by 4? That's 5. So my final answer is x equals 5. Right, next question that I'll do it silently and then I'll talk through it. And then I'll give you another your turn one to do. So there's my final answer, x equals 32. And you may think, well, I can see that it's going to be 32 because I know 32 divided by 4 is 8. But I'm trying to draw home this method to you because when this gets harder, we need this method of saying what we're doing to both sides. So by saying what we're doing to both sides, I mean putting in the times by 4 and putting in, you don't have to put in arrows, but I know from teaching classes previously that they quite like to do it as they're working down the page. So what that means is I've times both sides by 4 because at the moment x is being divided by 4. So to do the inverse of that and get rid of it, I multiply by 4. If I multiply the left hand side by 4, I have to do the same to the right hand side, remember, because do the same thing to both sides. So then I do 8 times 4, which is 32. Right, I'm going to give you one to do now. So have a go at that question, and then I'll go through it now. So remember, we're working down the page. What is happening to x at the moment? That's a good question to ask yourself. What's happening to x? Well, it's being divided by 4. Inverse of that, times by 4. Whatever I do to this left hand side, I have to do to the right hand side. So that will get me just x, because if I do the inverse of something, it will get me just x on its own. Because it's, yeah, I won't go into that now, but 20 times 4 is 80. So my final answer is x equals 80. And again, like I said, you may just be able to see, well, it's got to be 80 because 80 divided by 4 is 20. But I'm giving you this method to use and get used to this method, because when this gets harder, you'll definitely need a method to fall back on. Right, I've just got 2 more questions for you. And they're slightly different this time. They're not multiply or divide. These are called one-step equations because we're doing one step to get to our final answer every time. Here we're dividing by 4, dividing by 4, times by 4, times by 4. So this one-step equation that I'll give you, so again, you may just be able to see the answer, but I'm going to show you the method that you should be showing, and you'll find it helps you out so much when this gets harder. So let's talk through that. At the moment, we're adding 3 to x. So the inverse of that is to take away 3. Whatever I do to the left hand side, I have to do to the right hand side. So x add 3 take away 3, well, plus 3 take away 3 gets me 0. So that's why I'm left with just this x on this side here, because I've got plus 0. I could write plus 0, but that does nothing. So I'm left with just that x. 10 minus 3, because I'm doing the same to both sides to keep it balanced, is 7. No, I won't go into bar modelling for now, but alright, I'll give you another question to have a go at now. And again, I want you to show your working for how you got to your final answer. You may just be able to see what it is, but I want to see your working as I'm showing in my examples here. Right, I'll go through it now. So if you didn't get it, then make sure you mark it in red pen. Right, the question we should be asking ourselves, what is happening to x at the moment? We're taking away 3. What's the inverse of taking away 3? Well, that's to add 3 to both sides. We're working down the page. If I do take away, or negative 3 add 3, then I get 0. So I can do, again, I could say x plus 0, but there's no point in doing that. I can just write x, because plus and 0 does nothing. Then 10 add 3, 13. So my final answer is 13. There's just one final example I'd like to show you of similar to this one here, but instead I'm going to change it. Now, people really struggle with questions like this because they're like, well, how do I know what the inverse is? Because here I'm told that we're adding 3, but here it just looks like it's a 3 on its own. So how do I know how to get rid of it on this side and get x on its own? Well, that really is a positive 3 because there's no negative sign in front of it. It's a positive 3. So we can do exactly the same working as before, and we can take away 3 from both sides. So don't be put off, because remember, these can be written either way around. It's the same question as this, just with the 3 and the x switched around. So we're going to do the same thing to both sides, take away 3, and we're left with x equals 7. Right, if you're not sure on anything, it was really useful last time when somebody said I really struggled with, I think it was ratio work. It was really helpful to know that. So if you found it hard, then let me know and I can try and help you out. I'm going to set a maths watch on this stuff tomorrow. So yeah, it's going to be beneficial to you if you let me know that you struggled with it. Have a great rest of your day.